All right, so let's spend a second and look at ellipses. Just because we're trying to do, what was this? It was 12.3, number 11. Okay, and basically we're just like, I don't know. I don't remember how ellipses work, so we'll figure it out. Okay, so I'm trying to draw level curves for this thing. F of x and y is x squared plus 2y squared. Okay, and like maybe the, I don't know, maybe the dumbest thing I could do is draw the which level curve first.
0, 0.
Yeah, draw the 0 level curve first, right? Because that one's easy. Okay, so if I set 0 equal to x squared plus 2y squared, all right, what do you get?
0.
Yeah, they both got to be 0, right? So out of this, you just get the point 0, 0. So maybe over here, I'll draw my level curves, and I'm just doing, okay, point. Oops, I probably don't need to label 0, 0. What do I do? What do I need to label about this level curve? Oh yeah, Meryl likes you guys to have your axes labeled. I don't care. If they're the usual, you don't need to label them. But we should label that that thing is the z equals 0 level curve, right? Okay, now we might say, all right, the next one is, I don't know, like the 1 level curve for something, right? Is 1 is x squared plus 2y squared. And now we're thinking like, okay, yeah, that's an ellipse, right? What does the equation of an ellipse look like?
X squared over a squared plus y squared b squared.
Okay, so I'm thinking to myself, this is a x squared over a squared plus y squared over b squared equals, what's on the other side? Yeah, ellipses don't have a radius, right? They have 2 radii, which are right here, the a's and b's. So this equals 1. You guys remember that? Okay. Put this in your brain, you're gonna need it. Ellipses look like this. And I need to make this thing look like an ellipse, right? Okay, so first things first, I have the 1. Look, I'll even fill in this other thing for you. Right? But what's wrong?
2y.
Yeah, I have a 2 on the top, and I need a b squared on the bottom, right? You guys all see that? So I need to put a y squared here, and then I need to put something here that's going to make this work. So it's going to be there's going to be a root 2 in there, right? Because I'm going to need to square this thing. And it's got to be a 1 over so it ends up in the right spot. Cool? And so then what are your major and minor axes? So your major radius is the big one, right? That's your 1 in the x. And 1 over root 2 is smaller than 1 at least, right? And that's in your y direction. So your ellipses go out to 1 and minus 1 in the x and up to 1 over root 2 and down to minus 1 over root 2.
So that tells us it's growing faster along the y-axis, right?
No, you said 1 over.
Yeah, good.
The z is not.
So,
Oh, okay.
yeah, so the ellipse, right, is longer on the x direction, shorter on the y's, which means the function is steeper along the y-axis because those ellipses are more crammed together there. You guys all see that? So there's a lot of layers to this stuff, right? So like this is my z is 1 level curve. How many of these was this supposed to get for this problem?
64.
4. So how do you get the others? What do you do?
Scale and multiply by.
Yeah, and there's going to be some kind of scaling of this ellipse, right?
Is it
So
just
maybe
like-
let's do one more and figure out how. So if we do the 2 level curve, that's x squared plus 2y squared, right? So then what?
X.
Divide both sides by 2, right? That'll get you your 1. And then you got 1 is x squared over 2 plus y squared. Right? And so you got 1 is x squared over the square root of 2 squared plus y squared over 1 squared. That's cool. Okay, so that one's going to be 1 in the y direction. Sorry, I'm trying to eyeball in my head the relative sizes between 1 and 1 over root 2.
1 over 2 is like 0.74 or something.
No. Root 2 is like 1.4, so 1 over 1.4 is, I don't know. At any rate, I'm going to assume it looks like this, and root 2 is like 1.4, so that's out here, if, give or take. And so then you need another level curve, right? And at some point here, it becomes really handy to put colors on these. Ah! Shit. And so that's your z is 2 level curve, right? So now I'm up to 3. And then you do this whole rigmarole for one more. And you'll get these kind of, yeah, they're ellipses and they go out, right? So, can you guys tell me what this thing looks like? They get crammed in closer, by the way, as you go out.
It looks like an elliptical paraboloid, like that goes.
It looks like an elliptical paraboloid. No, 7, it is an elliptical paraboloid. What does it look like?
Like a squish paraboloid. It looks like a bowl.
Yeah, this is a satellite dish, right? That's not round. You guys see that?
Yeah.
Right? I can think
It's like
maybe if I slice in the y direction, right? Like if I pitch the y's. You guys see this? Like if I set y equals 0, I get x squared, right? That's a parabola. If I set x is 0, I get 2y squared. That's also a, yeah, it's a parabola, it's just steeper, right? You guys see that? And then putting them together makes a paraboloid, right?
Yep.
And the cross sections we just found out are ellipses with a squished y. Cool? Questions, Seals?
Yeah, when it says label at least 4 contours, did you count your 0, 0?
I did. The 0 contour is one of them.
And we can do that on our.
And you can do that.
Awesome.
And if you want to be really friggin' lame, now I'm not going to show you that trick. Okay, fine, I'll tell you. If you want to be super duper lame, where's the z is z is negative 1 contour?
It doesn't exist.
There just isn't one.
So I.
So we've labeled 4 contours.
Oh my god.
We've in fact labeled all of the negative integers and also these
That's
ones.
impressive.
Right? Like they're just not there, so they don't. It might be a good idea to like write some note about that off on the side if you employ that trick. Please do not give me a blank picture and say I labeled all the negative integers. Cool? like I'm saying right now that's a dirty trick and I'm not giving points for it, I will laugh and maybe give 1. 1 is not 10.